Hi guys, now we are going to solve this nice Olympiad problem. 3 to the power a minus 2 to the power a is equal to 65. We had to find out the value of a. So now we start the problem. Here 3 to the power a, you can write without changing this value 2 times 1 by 2. Multiple and divide by 2, no? Then this 3 power a, you get the actual term minus 2 to the power a whole to the power multiple and divide by 2. So we have 2 times 1 by 2. These two terms get cancelled. You get 2 power a is equal to 65. After that, what you are going to do is, we have a to the power m whole to the power n is equal to a to the power n whole to the power m. We can interchange the powers here. So using this, we can interchange this power here. Okay. So you can write this to be 3 to the power a times 1 by 2 whole to the power 2 minus 2 to the power a times 1 by 2 whole to the power 2 is equal to 65. Or you can write this to be 3 to the power a by 2 minus 2 to the power a by 2. That is, here you have whole square, no? So whole squared is equal to 65. Now, for our simplification, we take 3 to the power a by 2 is equal to x and 2 to the power a by 2 is equal to y. After the substitution, our equation becomes x squared minus y squared is equal to 65. Okay, so we had to find out the value for this x and y and substitute here. We can get the answer for a. So what we have to do is, that is 65. You can arrive 5 times. 5 times you have 13 times 5 is 65, and this is not that is factors we can't find out. So 5 times 13 you have 65, and also so 65 is having the factors 1 times 65 and 65 times 1 and 13 times 5, 5 times 13. So these are the possibilities we have. So we have two cases. First case is case 1. We have that 65 can be written as 13 times 5. So x squared minus y squared is equal to 13 times 5. You can write it, or 5 times 13. And next case is x squared minus y squared is equal to 65 times 1 or 1 times 65. So we have two cases to solve. Okay, so we have case 1 and case 2. These two cases we have to solve. So coming to the first case, x squared. So we are starting with the case 1. X squared minus y squared is equal to 5 times 13 or 13 times 5. Anyway, you can write it. So we'll write it as 3 times as 13 times 5. Okay. So here x squared minus y squared can be written as x plus y into x minus y, isn't it? This is the formula. A squared minus b squared can be written as a plus b into a minus b. So using this formula, we can write x squared minus y squared as x plus y times x minus y times 13 times 5. Okay, so suppose you're taking 5 times 13. Here x plus y is the largest value and x minus y is the smallest value, comparing these two terms. So in the same way, while writing these two terms, you have to write the highest value here and lowest value here. Suppose if you are writing x minus y times x plus y, you just write 5 times 13. Both the ways you can do it. Now, comparing the terms here, x plus y is equal to 13 and x minus y is equal to 5. Suppose if you are writing this as the same term as x minus y in the formula, instead of x squared minus y squared, instead of this, if you are writing x minus y times x plus y, you just use as 5 times 13. Okay. because x plus y is the largest value and x minus y is the lowest value. Now we have to solve these two equations. X plus y is equal to 13 and just write x minus y is equal to 5. So adding these two terms, 2x is equal to 13 plus 5 is 18, or x is equal to 18 over 2 is equal to 9. So x is equal to 9. Substituting x is equal to 9 in any of these equations. So here any one you can substitute. 9 plus y is equal to 13, or we have y is equal to 13 minus 9, which is equal to 4. So x is equal to 9 and y is equal to 4. Okay. Now we have to substitute the values in our original term. So here x is equal to 3 power a by 2. Here we have to substitute. So here x is equal to 3 power a by 2 is equal to 9 and y is equal to 2 power a by 2. So y value is 2 power a by 2 is equal to 4. So this is the term we have. Now we have to make the base to be same. Then we can equate the powers and easily get the value of a now. Okay. So 3 to the power a by 2 is equal to, your 9 can be written as 3 squared, isn't it? In the same way, 2 to the power a by 2 is equal to 4 can be written as 2 squared. So from this we have base is same. So a by 2 is equal to 2 and here you have this base is same. So again a by 2 is equal to 2. So a is equal to 2 times 2 is 4 and here a is equal to 4. 2 times 2 is 4. So we have two possible values for a. So a is equal to 4 and here a is equal to this, a is equal to 4 here. So we get a is 4. So this is an integer value. We got it in our first case. Suppose we are going to do the second case now. What is our second case? Second case is x squared minus y squared is equal to 65 times 1. So here x squared minus y squared is equal to 65 times 1 we have, or you have x plus y times x minus y is equal to 65 times 1. You can equate that x plus y is equal to 65 and x minus y is equal to 1. That is comparing these two terms and these two terms. Now we have to solve this. So here what is the two equations we got? X plus y is equal to 65 and x minus y is equal to 1. So when you're solving this, 2x, these two terms get cancelled. 2x is equal to 66. We are adding this and x is equal to 66 over 2, which is 33. And when you're substituting x is equal to 33 in any of this equation, 33 plus y is equal to 65 or y is equal to, here you have 65 minus 33. So which is equal to 32. So 32, 32. So y is equal to 32. Now what is our again x is equal to, what is our x? X is equal to 3 power a by 2. So we are going to substitute that 3 power a by 2 is equal to 33 and y is 2 power a by 2 is equal to 32. Now here we can't make this base to the same. So we are taking log on both sides. Log 3 to the power a by 2 is equal to log 33. Or you can take this a by 2 to here. A by 2 log 3 is equal to log 33 using log of a to the power b is equal to b log a formula. And here you have a by 2 is equal to log 33 over, you take this log 3 this side, log 3, or you can write this to be log 33 base 3. So a is equal to 2 times log 33 base 3. This is the value of a now. Next, we are going to find out another a value using this. So here also we had to take a log on both sides. We have log 2 to the power a by 2 is equal to log 32, or you have a by 2 log 2 is equal to, using this formula, log 32, or you have a by 2 is equal to log 32 over log 2, or you can write this to be log 32 over 2, sorry, base 2, or a is equal to 2 log 32 base 2. This is the another value for a. So if you want the integer solution, then you can take a is equal to 4 and a is equal to 4. And if you want a non-integer solution, then a have 2 log 33 base 3, or a is equal to 2 log 32 base 2. And if you want to check that, suppose substituting a is equal to, here suppose we check for the integer solution, a is equal to 4 and a is equal to 4. Our problem is, this is our problem, here 3 to the power a minus 2 to the power a is equal to 65. So we have 3 to the power 4 minus 2 to the power 4 is equal to 6. 3 to the power 4 is 81 minus 2 to the power 4 is 16 is equal to 65. What is 81 minus 16, which is equal to 65, is equal to 65. So a is equal to 4 is the one solution, integer solution for this problem. In the same way, you can substitute a is equal to log 33 base 3 and 2 log 32 base 2. You can get the value as 65. Thanks for watching. Subscribe our channel for more videos.